Hello everyone, thank you for joining us here at Alberta Lake Management Society with our Summer Lakekeepers program. And here we're going to show you step by step how you will successfully sample your sites this year. Again, thank you for your interest and passion in participating in the Lakekeepers program this year. With your assistance, we are able to collect water quality data that allows us to fill gaps that exist in many parts of Alberta, and in part helps us to promote understanding and comprehensive management of lakes and reservoirs in their watersheds. We appreciate all your help. We also offer a winter program, so if you're interested in joining that, you can check out our Winter Lakekeepers program on our website, alms.ca. Before you head out to sample, you will need to make sure that you have all your proper gear ready to sample. ALMS will supply you with most of the things you will need in order to sample. This includes your probe kit, the chlorophyll kit, the bottle sets, a tape and weight, a Secchi Disk, field sheet, and your field manual. There are a few things that ALMS will not supply you with, such as a boat, the boat gear and all that is included with that, which includes an anchor, paddle, or a rope or anything like that, and also life jackets. This list will also be included in your field manual, so please be sure to read that over before going out. There are some steps that you will want to do before heading out in the field. So you want to make sure that your probe is charged. You can check on the handheld on the top right side of the screen. Will have the battery amount, so make sure that that is charged up before heading out. You will also want to fill out your Lakekeepers Informed Consent form. You will want to check the weather and make sure that there are no signs of thunderstorms or that the wind is somewhere less than 20 to 25 kilometers. Just making sure that it is safe on the lake to go do sampling and that proper sampling can be done. If it's too windy, this can disturb the results we get for the samples. Next, you will want to calibrate. This includes either calibrating dissolved oxygen and conductivity or just dissolved oxygen. The ALMS staff will let you know what parameters you will need to calibrate for. Then you will want to make sure that you freeze your ice packs the night before so they are nice and cold before you go out to sample, and this will protect your samples from the heat. You will also want to let our office know that you are sampling so we can prepare to receive the samples afterwards. Next will be prepping your boat. So this will be including things like making sure there is enough gas and oil in the boat to do the sampling event, that you have all your safety gear, which includes your paddle, your baler, your life jackets, and anything else like that you may need. You will also want to pack up some of the equipment that our office has sent you. So not everything that we send you will be required to be on the boat, but here is the list of the things that we send you that you will need. So make sure that you pack your field manual and your field sheets, tape and weight, the Secchi Disk, the YSI probe and handheld, some nitrile gloves, the cooler that has the cold ice packs in it, and in this cooler you will want to make sure you have your sample bottles to sample with. Now it's time to go over calibration. We'll start by attaching the probe cord to the handheld and turning on the handheld, removing the gray sleeve and then the metal covering. Be careful when you are removing it that you don't nick the end of the probe or hit the sensors. And we will take a Kim-Wipe that's in your kit and dab the probe tip on and around, just making sure there's no moisture. And then we will inspect the probe sensor to make sure that there's no nicks or bumps or anything like that. Once we've inspected it, we can put the metal guard back on carefully and screw it back on till it's tight. And in the gray sleeve will be a yellow sponge that we'll make sure is in there, and we will put some pure water. You don't need a lot, just a little bit, just to wet the sponge. So once that's on, we will put the gray sleeve back on and stand the probe upright while we begin to calibrate. Allow your probe to stand for about a minute just to allow the probe to acclimate to the moisture from the wet sponge. We will begin with dissolved oxygen calibration, so you'll hit the calibration button and look for ODO, click enter, then DO %, enter, and it'll come up with this screen, and you'll see that there is a barometer value with some numbers, and we're wanting to take note of what's written there, so we'll write that down on our field sheet. And as it's calibrating, we'll see the lines go across the screen, and we want to make sure that there's no dips or spikes in the lines, just to make sure that it is stable. And once we're confident it is stable, we will accept this calibration. So we'll highlight that and press enter, and you'll see calibrating sensor, and it was successful. With this, you'll know that you've done it correctly and you're ready to go on to connectivity. So you will take your calibration solution that will be in your kit and take note of these numbers because we will use them later, and your graduated cylinder. And we will take our probe and take the gray sleeve off, leaving the metal covering on for this one. And we will fill the graduated cylinder with the calibration solution. And we want to fill it so that it's halfway full, and then we will put our probe in the cylinder. And so we see here, this is the calibration sensor. We want to make sure that that is completely submerged in the calibration solution. So when you put it in, if it's not completely full, we'll just top it up so that that sensor is covered. And we'll flick it so that if there's any air bubbles that they will escape. We will let this sit for about a minute to acclimate to the solution. Once that's completed and we're making sure that there's no air bubbles, we will go to our handheld and press calibration, this time looking for conductivity, enter. We'll click on specific conductance, and then we will be at our screen again, and we will click on the calibration value, and we're going to change that to those numbers that are written on the calibration solution bottle. So for here, it's 979. We'll enter, and then we'll see that calibration is beginning. We're seeing those lines go across, and we will let that sit for about a minute. And we'll watch those lines, making sure there's no spikes and no bumps so that it's stable. And after a few minutes of making sure that that's stable, we will click accept calibration. We'll see again that it'll say calibrating sensor and calibration successful. We will then return to our main screen. And here we will go through our values that we will be looking for. So we will have our temperature that is measured in Celsius, our dissolved oxygen that's measured in milligrams per liter, and our conductivity that's measured in microsiemens per centimeter. Most of our ALMS probes do measure all three parameters now. However, there are a few that only measure temperature and dissolved oxygen still, and will only display these on the screen. An ALMS staff member will let you know what your probe is capable of measuring. Once you are packed and ready to go, you are ready to head out and sample. We encourage you to choose your sample site that is either at the deepest known part of the lake or an area of concern. If you need assistance on choosing a site, contact our staff at ALMS and we can help you out. Since many of you will be sampling more than once this season, we do encourage that you choose the same sample site location as the previous site visit. When you are choosing a site, please do not choose a site that is close to the shoreline. The deeper the location, the more robust the data that is collected will be. When you arrive at your profile site where you will be sampling, there's a few things that you will do before you start getting ready to sample. You will want to make sure that you turn off the boat to avoid any contamination when you collect water samples. You'll want to lower your anchor so that you can stay at that same spot the whole time you are at this location. You will then want to write down your sample coordinates, so you want to write the coordinates of where you are sampling at that moment, so you can use your phone and GPS to record those on your field sheet. And then you will want to start filling out your field sheet and labeling your bottle sets. It is important to label them before the bottle gets wet. It's a lot easier to write on then. You will want to rinse your bottle sets 3 times each. Once they are rinsed, you can then fill the bottles. And then you can start getting ready to take some data. We'll start by filling out our field sheet. So here we will include our lake name and also the location name. Your location names are reference points on the lake that aid in identifying the sampling location, like a boat launch or North or South Basin, anything like that. And the names of the volunteers that helped out with sampling for this event. We will also include the date of sampling and the time that we started sampling. And we'll also include what kit number. It will be written on the side of the kit. There is also a section here to fill out the hours spent sampling. It is important to fill this out before shipping or dropping off your samples at the ALMS office. This helps us keep track of all the help that we get throughout the years from volunteers like yourself. This includes things like your time it takes you to calibrate, driving, the time it takes to sample, and also if you have to filter. We also have some environmental observations that we will get you to note down. These can be found on any weather app on your phone to get this information for air temperature, wind speed, and wind direction. And also we will estimate about how much cloud coverage there is. To estimate this, you will look above the lake and estimate how much of the lake is covered by clouds as a whole, and then record as a percentage on your field sheet. We will also note if there has been rain within the past 24 hours. There are different sites that we can use to find this information of the amount. We will include the links to these websites that are useful down below in the description. In the evidence of cyanobacteria section, we will look at the water and select if it's clear, if there's particles in the water, or if there are streaks in the water as such, or if there are scums forming on the surface. So next we will be taking our Secchi Disk readings, and when we take our readings we want to make sure that we remove our sunglasses so that we can take the proper readings. So we will lower our Secchi Disk into the water, and we want to make sure that it goes straight down into the water as best as we can. We will lower this until the white part of the Secchi Disk disappears. Once we see that, we will take note of the depth using the little tabs on the chain. The tabs will be marked as such. This can be found in your field manual. White is every 0.1 meters, orange is every 0.5 meters, pink is every meters. If there's pink and yellow, it's 5 or 15 meters, or if it's pink and green, it's 10 meters. You will use this to note down the depth at which our Secchi disappears. And then we will bring it up just slightly until it just reappears again, and we will take the measurement at that depth as well. So for our example with this Secchi reading, we will take the measurement at which the Secchi disappeared, which in this case was 0.6 meters. And then we will take the measurement at which it reappears when we pull it back up slightly. So in this case, it was 0.4 meters. And so then to calculate our average, we are going to take those two numbers, so our 0.6 meters, and add our 0.4 meters. We'll add those together, and that will give us 1 meter. And then to calculate our average, we will divide that by 2. And in this case, we will get an average of 0.5. So then we will write this as our Secchi measurement. As well, when we're doing our Secchi depth, we will note what color the Secchi disk was, lowering it into the column. We will also take the coordinates of where we are sampling. You can use your Google Maps or Apple Maps or whatever kind of maps you use to get this information. Next, we will do our tape and weight to measure bottom depth. So we will lower our tape and weight into the water until we feel it hit the bottom. You will feel the line go slightly slack when you hit the bottom. So when it does have that feeling, you will grab where the water ends on the tape and you will take note of this measurement. So in this case, we see it touches the 30 mark and the 8 meter. So we will jot down 8.3 meters and make sure to measure in meters. Next, we will get our probe ready to take our probe measurements. So we will remove the gray sleeve and lower it in so that the connectivity sensor is just below the surface of the water. This is our marking guide that's taped on the probe. So you can find this in your field manual to refer back to it. But each color marking represents a different measurement on the probe. So we'll have in the blue, this is found right on the main part of the probe sensor at 0.1 for your first reading, and then a second marking in pink at 0.5. Then we have our orange tape, which represents 1 meter. So this will be marked as we will be taking measurements at every 1 meter after those first two measurements. For the 5 meter, the 15 meter, and the 25 meter measurement, we will have it marked with pink and orange. And for our 10 meter and 20 meter and 30 meter marking, we will have that marked as blue and orange. So again, you can refer back to this in your field manual if you need further clarification. We will go to our handheld, and on our main screen will be our readings. When you first put it in the water, wait a couple minutes for the values to stabilize and stop rapidly changing. It's likely the DO will never stop moving completely, so wait till it has slowed down significantly and use your judgment to record the reading on your field sheet. Once your numbers have stabilized, we can jot down the values that we are reading at that point. So in this case, we're doing our first reading, which is at 0.1 meters. So we will take the values of the temperature, the dissolved oxygen, and the conductivity. And then you will lower it to the 0.5 meters marked in pink. Once those are done, we will move it down to the 1 meter marks, which are marked in orange. And you will take depths at every meter after this until you reach about a meter or a half meter from the bottom. So in our case here, our bottom depth is 8.3 meters. So we are going to go down to 8 meters and we'll stop taking measurements at the 8-meter mark. For another example, if you measure your bottom depth at 5.1 to 5.9, you would then want to measure up to 5 meters. But if you measure your bottom depth at exactly 5.0 meters, then you would want to measure at 4 meters, just so you don't hit bottom in your measurements. This is why it's very important to measure your bottom depth in meters only and not in feet. It just makes this part easier to calculate up to what meter you will be measuring to. When you hit the bottom, you do not need to record a depth reading here. All your values will be thrown off due to the sediment, so we do not need to record when we hit the bottom. Now we can move on to our bottle set. We will make sure to label our bottles before we put them in the water. It is easier to write on them when they are not wet. So we'll put the name of the lake, location, the date, and also the time. Make sure all your bottles have the exact same time and that they match your field sheet. So the time you write on one, you're going to write the same on all of them. It is important to ensure that your samples are labeled so that there isn't a chance for them to get mixed up with other samples coming into the office. After all your bottles are labeled, we can start collecting the samples. So with this G2 preserved bottle, we'll remove the sulfuric acid vial. We will open up the bottle and put on our gloves. We will take the bottle, take the lid off, and we will place it into the water as deep as we can, and we will fill it up. We will dump out some of the water so that there is some headspace to put the sulfuric acid in. So we will open up the vial and pour it in. Be very careful because this is sulfuric acid. And we will put the lid back on that and we can put it in the cooler. And we will put the lid back on the bottle, nice and tight, and give it a shake. Then we will take our next bottle, our microcystin, and do the same thing. With our microcystin, we will pour out enough because we will freeze this, so we want to have some room at the top for it to freeze. Next is our chlorophyll bottle, so repeating the process, filling it as much as we can, putting the lid back on, and placing back into the cooler. Next is our isotope bottle. Be careful with this one because it's quite small. And again, same thing. We will place all our bottles in our cooler that has the ice packs in it. When we bring our samples home, we will want to store our microcystin in the freezer. Make sure that there is enough space for it to freeze that it won't break the bottle. And then the rest of our bottles will go into the fridge as they don't need to be frozen. We can store our chlorophyll sample in there until we have time to filter, and we can keep them here until we are ready to send our samples back to the ALMS office. Next, we will filter our chlorophyll sample. So you will put your chlorophyll kit on the table and your chlorophyll bottle, and we will take out all the supplies we need, and we will open our bottle so that we can pour the pure water into that bottle that we will use for rinsing later. Then we can clear off our cooler so we have some space on the table. And we will take out our bag that will have our gloves in, and you will want to put your gloves on so you don't contaminate the sample. And we will attach the hand pump hose to the filter apparatus, and we will take everything out of the bag just so then it's accessible. And we will take 3 petri dishes out of the bag because we will use those for our filter samples. And we will unscrew the top of our filter apparatus and we will grab our tweezers and we will place one of the filters that we have provided. We'll place that onto our filter apparatus, making sure it is nice and centered, and make sure you just grab one. Sometimes they kind of stick together, so you might just have to pry it apart a little bit so you don't rip the filter. And then we will put the lid back on the filter apparatus. Then make sure that you turn off the light. The less light shining on the chlorophyll sample, the better. It won't degrade as quickly. We will take our chlorophyll bottle and we will invert it 4 to 5 times just to make sure that everything has been mixed and nothing is settling on the bottom. And we will pour a portion into our graduated cylinder. Start with a little bit at first, and you will jot down the number that you filled the graduated cylinder to. So in this case, we measured 48 mils for this first bit. And we will open up the top. We will use the pure water to wet the filter paper and hand pump it a little bit. Then we will pour that 48 milliliters into the apparatus and hand pump it so that it pours through the apparatus. Then we will take the top off and we're going to check and see if there is any hint of color. It is a little hard to see in this photo, but we want to see just a hint of color. And you may have to take the filter paper off and kind of twist it around just to see if there is. The filter paper might have different colors on it as seen in these pictures. You can have different kinds of cyanobacteria, so just to note down the color and write it on your field sheet. If there isn't any hint of color, we will put it back on the apparatus and we will measure out a bit more, about another 50 mils, and pour that in and hand pump it again. Once the water is through, we'll check again to see if there is any color on the filter paper. So again, we will take it off because it's a little tough to see sometimes. And we can see, it's still a little bit hard to tell, but there is color on the filter paper. So we will continue on to preserve the filter paper. But if you still don't see anything, you will just repeat the process again. Just make sure that you do not filter more than 300 mils, and also jot down the number on your field sheet and the color of the filter paper. We will then rinse our graduated cylinder and pour that onto our filter paper, and we rinse it 3 times. And then we will rinse the sides of the filter apparatus 3 times as well, trying to get anything that might have been left over or stuck to the sides, and hand pump it through. Once we've done this, we will go into our little baggie where there is magnesium carbonate, MgCO3, and we'll open that up and take our dropper, and we will take a little grab of that, and we will put about 4 or 5 drops onto the filter paper. Place the cap back on the magnesium carbonate and put the dropper and the bottle back into the sandwich bag. And again, hand pump just to make sure all the moisture has been sucked through. We will take the lid off and we will take our tweezers and we will fold the filter paper in half and then in half again so that we have it in quarters. And we will take our petri dish and open it, and we will put the filter paper in the petri dish, and we will wrap the petri dish in tin foil. This will keep it from being exposed to any light, so then it's easy for transport. Then we will take our labels and we will fill out the label. Like our bottle labels, we will put the lake name, the location name, the date, and we will put the amount that we filtered. So we'll refer back to what we wrote on our field sheet. So for this amount, it was 98 mils. And we will take that label off and put it right onto the tin foil that we wrapped around our petri dish. And that is it for that first petri dish. And we'll put it in the Ziploc bag so that it doesn't get wet during travel. And then we will repeat the process 2 more times so that we have 3 different filter papers in 3 different petri dishes. We will repeat this process, but keep an eye on the bottom part of the apparatus that is filled with water. If it's full, you will want to detach it from the top piece, and you never want to pour this down the drain so we can avoid any spread of any possible invasive species. Instead of pouring it outside, if you're still by the lake, you can pour it back into the lake. Otherwise, if you are at home, just make sure that you pour that excess back into the waste jug and send it back to the office. We will put those filter samples in our freezer to keep them frozen until we can ship them back to the ALMS office. We will now go over the shipping protocols. Before shipping, always make sure you've included all your samples, including your microcystin and chlorophyll filter stored in the freezer if your protocol calls for them. Please include a copy of your field sheet inside the cooler. To keep it dry, place it in a Ziploc bag before adding it to your samples. Always include a couple of frozen ice packs to ensure your samples stay cold during transport back to our office. Once your cooler is fully packed, tape it shut securely to prevent anything from falling out. ALMS staff will have already set up Purolator return labels for your equipment. These labels can be found in your probe kit and will either be for the entire sampling season or for individual sampling rounds, depending on your setup. Each sample will be identified for you, indicating whether it's for the probe kit, filter kit, or sample cooler, and will have a specific weight assigned. Make sure to attach each label to the correct piece of equipment when shipping back. Put the appropriate labels into the provided sleeve, with the barcode facing out and visible. Tear off the tape and fold the top part over to secure the label in the sleeve. Press it to the top of the cooler and make it secure. If you're keeping your equipment for the full season, only attach the sample cooler return label and send it back to us. You can hold on to the chlorophyll filter and probe kit until your last round of sampling. On your final round, you will return everything together, your samples, probe kit, and chlorophyll filter kit. Your cooler is then ready to be dropped off at your nearest Purolator location. You can find a map of nearby locations in your field manual. Finally, please notify the program coordinator once your samples have been shipped. So there's a couple things that you will want to note before you decide on a date to sample. So make sure that you don't sample on a Thursday unless you are able to drop the samples back off at our office the same day. Also, please do not ship samples out or complete sampling on Fridays or Saturdays, as our office is closed over the weekends. The field manual will list stat holidays that our office will also be closed. Please refer to that. Also, please refer to the Purolator location and cutoff times in your field manual's appendix, and to send us a picture of the tracking number so we can keep an eye on the shipment. As you head out into the field, always refer to your field manual provided in your probe kit for the most up-to-date bottle sets and sampling protocols. It's your best resource for ensuring that your sampling is accurate and consistent. And remember, if you ever have any questions, run into issues, or just need a little troubleshooting support, don't hesitate to reach out to us. We are here to help. You can reach us at our email, lakekeepers@alms.ca, or you can call our office at 780-702-2567. From all of us at ALMS, thank you for your participation and continued support. Without your efforts, we wouldn't be able to build such a robust and meaningful data set on Alberta lakes or advocate for their health and protection. Happy sampling and enjoy your summer out on the lake.